In this video, we will cover Section 4-4, Part 3, Day 1, Solving Quadratics by Factoring. First, let's discuss the steps we need to follow to solve a quadratic by factoring. First, we need to determine two numbers that multiply to C and add to B. And if C is positive, then both numbers are going to be positive, so a positive and a positive, or they'll both be negative, or a negative and a negative, since they have the same sign. If C is negative, then they're going to have different signs. So one is positive and one is negative. It doesn't matter which order they're in. Then you're going to fill the terms into the factors. So it'll be x fill in the blank and x fill in the blank like we've done before. And then the new part is that you're going to set both of these factors equal 0 and solve the equation separately, giving you two answers. So we're building upon what we've already done with factoring quadratics to now solve to get an answer. So first, we are going to factor this expression. So we need to determine what two numbers multiply to negative 28 and add to 3. So if I list all my numbers that multiply to negative 28, if you do negative 28 divided by 1, it gives you negative 28. If you do negative 28 divided by negative 1, it gives you positive 28. If you do negative 28 divided by 2, it gives you negative 14. If you do negative 28 divided by negative 2, it gives you positive 14. If you do negative 28 divided by 3, it gives you a decimal, so it doesn't work, and neither does the negative version. Negative 28 divided by 4 gives you 7, or negative 7. And negative 28 divided by negative 4 gives you positive 7. And then if I continue, I have negative 28 divided by 5 is a decimal, so it doesn't work, and neither does the negative version. Negative 28 divided by 6 is a decimal, and so is the negative version, so that doesn't work. And then the next number we would test would be 7, which we've already checked, meaning that we have all the possibilities listed here. Now if we want to check to see which set adds to equal 3, we have to add each pair. So if I add the 1 and negative 28, would give me negative 27. If I add the negative 1 and 28, would give me positive 27. If I added the 2 and negative 14, would give me negative 12. If I added the negative 2 and 14, would give me positive 12. If I added the 4 and negative 7, would give me negative 3. And if you add the negative 4 and 7, gives you positive 3. Now, if we're looking through the list, the pair of numbers that adds to equal positive 3 is the last example. So our two numbers that we are using are negative 4 and 7. Now we can rewrite our factors. So this becomes x with the blank and x with the blank equals 0. And we're filling in with the values that we selected. So if we had our first number was negative 4, so we can fill in a minus 4, again pulling from that bottom number that we chose. And then the other number we have is 7. So I can fill in a 7, and since there isn't a sign, we assume that it's plus 7. Now that we have this, the new part is that we are going to solve with the factors. And what that means is that you're going to take both equations and set them equal to 0. So we can say we have x minus 4 equals 0 and x plus 7 equals 0. Now if I wanted to solve the equation on the left, I would add 4 to both sides. So the 4's cancel, so it becomes x equals 4. And if I want to solve the equation on the right, I would subtract 7. So the 7's cancel, so it becomes x equals negative 7. Which means that our two answers are x equals 4 and x equals negative 7, which you can rewrite as you want it to be x equals 4 or -7. In this next example, in order to solve by factoring, we first have to determine which pairs of numbers multiply to equal 18 and add to equal 11. So if I start by listing the numbers that multiply to equal 18, you first can divide 18 by positive 1, which gives us a value of 18. And 18 divided by the negative version, or -1, gives us -18. Then if I divide 18 by 2, it gives us 9. And 18 divided by the negative version, so -2, gives us -9. Then I next can check 18 divided by 3, which gives us 6. And 18 divided by the -3 gives us -6. The next number we would check would be 4, and 18 divided by 4 gives us a decimal, so it doesn't work, and neither does the negative version. 18 divided by 5 gives us a decimal, so it doesn't work, and neither does the negative version. And then lastly, we have 18 divided by 6, meaning that we have all of our possibilities listed. So now if I add each pair to check which set adds to equal 11, if we do 1 plus 18 would give us 19. -1 and plus -18 equals -19. 2 plus 9 equals 11. -2 and -9 equals -11. 3 plus 6 would give us 9. And -3 plus -6 would equal -9. Now, if we want to pick out which set of these numbers adds to equal 11, the pair of numbers that adds to positive 11 is the 2 and 9. So if I rewrite this as my factors, so x with the blank times x with the blank equals 0, I'm going to use the numbers 2 and 9 to fill into my factors. So the first number I have is the 2, so we can fill this in to be 2, and since it's positive, we're implying that it's x plus 2, so that fills our first blank. And then our second blank is the second number, which is 9. So since it's a positive 9, it implies it's plus 9 to fill in that blank. So we have x plus 2 times x plus 9. Now if I want to do the last part to solve, we have to set them both equal 0. So if I set x plus 2 equals 0 and x plus 9 equals 0. So to solve the equation on the left, I would subtract 2 from both sides. So you get x equals -2. And to solve the equation on the right, you would subtract 9. So we get x equals -9, giving us our two answers. So we can rewrite this as x equals -2 or -9. For our last example, we are also solving by factoring. However, this is one of our special cases because we know that quadratics should usually be written in the form. So it's ax squared plus bx plus c. So we're missing that middle term. However, we can rewrite this so it's x squared plus something x minus 25 equals 0. And since there is nothing there, this is really implying that this is plus 0x. Now we're going to solve just like we did for the other examples. So we want to determine which numbers multiply to -25 and add to 0. So if I first list the numbers that multiply to -25, if I do -25 divided by +1, gives me -25. -25 divided by -1 gives me +25. -25 divided by 2 gives me a decimal, so it doesn't work. -25 divided by 3 gives me a decimal, so it doesn't work, and neither does the negative version. -25 divided by 4 gives me a decimal, so it doesn't work, and neither does the negative version. And then lastly, negative 25 divided by negative 5 gives us positive 5. Now we would next normally check positive 5, however, it's already there, meaning all of our possibilities are listed. So if we want to check to see which one adds to equal 0, we have to add each pair. So 1 plus negative 25 equals negative 24. Negative 1 and 25 equals positive 24. And negative 5 and 5 equals 0. So the pair of numbers that adds to equal 0 is the last set. So if I now rewrite this as x with the blank times x with the blank equals 0, I'm filling in those numbers of 5 and negative 5. So I can first fill in my first number, which was negative 5. So it becomes minus 5 in the first blank. So I have x minus 5. And then my second number was positive 5. So I can fill in a 5. And since it's positive, we imply that it's plus 5, which gives me my second factor of x plus 5. Now lastly, we have to solve by setting both parts equal 0. So I could set x minus 5 equals 0 and x plus 5 equals 0. So if I solve the equation on the left, I would add 5 to both sides, so the 5's cancel. So it gives us x equals 5. And then for the equation on the right, you would subtract 5, so the 5's cancel. So you get x equals negative 5, giving us our two answers, which we can rewrite as either x equals 5 or negative 5, or since these are the same number, it's also sometimes written as x equals plus or minus 5, meaning it's the positive or the negative version of that number.